So let's review some exponent rules and how we would simplify some of these expressions. Let's look at b to the fourth. Let's first read it so we know exactly what we're being asked here. Simplify in such a way that your answer only contains positive exponents. Okay, so let's look at the first problem here. B to the fourth power all taken to the negative 2 power times negative a cubed times b to the fifth. Okay, so let's rewrite this in a way that kind of makes sense out of this negative sign, because if there's one thing that is sort of in our way before we even get started, it's that negative sign. So what we've really got is b to the fourth to the negative 2 times negative 1 times a cubed times b to the fifth. Could have put the cube either inside or outside that parenthesis. Okay, so keep in mind, it's not negative a cubed, it's negative 1 times a cubed. The reason that's important to remember is you get a different answer if you do it the other way, possibly. Okay, in this case, maybe not, but in many cases you would. You have to remember exponentiation comes before multiplication. So we group exponentiation and then we multiply. Well, negative 1 here is just a factor. We can pull it out in any order we want. So let's move it to the beginning. These are all just 4 factors. Let's rewrite this as negative 1 times b to the fourth in turn to the negative 2 power times a to the third times b to the fifth. Doesn't really matter if we put them inside or outside the parenthesis. Okay, so we can kind of ignore the negative 1 for now. Let's simplify this first one. This is a power to a power. When you have a power to a power, you multiply the exponents. So we've got negative 1 times b to the negative 8 power. Okay, and I can switch these orders. So I could put b to the fifth power next, and then I could put a to the third power after that. Okay. So now I can go ahead and complete this problem. It will be negative 1. I'll have to have the same base with 2 different exponents, which means I have to add these exponents together. So I have now b to the negative 8 plus 5 power times a cubed, which is the same thing as negative 1 times b to the negative third power times a cubed. Are we done yet? Well, this is certainly a little simpler than what we had, but it's telling us our answer should only contain positive exponents, and we've got a negative exponent here. We have b to the negative third power. How do we make that into a positive? We have to remember, I'll just kind of put this on the side here, that b to the negative 3 is the same thing as 1 over b to the third. And that is how you take a negative exponent and make it into a positive one. So let's go back to this. This is the same thing as negative 1 times 1 over b to the third times a cubed. And now we multiply everything out. We get negative 1 times a cubed over b cubed, which is the same thing as negative a cubed over b cubed, which is our answer. Okay, that is our answer. That is our final simplification. Let's go on to a trig problem here. Shift gears a little bit. We've got a question asking us to find the value of a trig function. Okay, it's giving us a triangle. Let's take a look at this triangle. Okay, where it's a right triangle. We see it has a right angle. We see it has one of its legs is 3. One of its legs is 9, and we don't know what the hypotenuse is. We don't know the size of the hypotenuse. Do we need to know the hypotenuse? Well, let's take a look at sine theta. This is theta. We need to find the sine of that angle. Remember SOHCAHTOA? SOHCAHTOA is a good shortcut for remembering how to calculate sines, cosines, and tangents if you're given a triangle. SOHCAHTOA means that the sine is equal to the opposite side over the hypotenuse. Let's go back to the triangle. What is the opposite side? What is the side opposite theta? It's 3. What is the length of the hypotenuse? We're not given it. But can we figure it out? Yes, using the Pythagorean theorem. Let's go ahead and use the Pythagorean theorem. I'll just write it up here. We know a squared plus b squared equals c squared, where c squared is the hypotenuse. That's what we need to know. A and b are 3 and 9. We've got 3 squared plus 9 squared equals c squared. This is the same thing as 9 plus 81 equals c squared. Therefore, c squared equals 90. Okay? C, therefore, is equal to the square root of 90. So we have the square root of 90 equals c. So that's our length of our hypotenuse. Let's go ahead and let's put it down here. Square root of 90. So we've got the sign. It's 3 over the square root of 90. But can we simplify this a little bit? Is there any way that we can simplify this because we'd like to get the simplest form? Well, we have a radical in the denominator. I think we probably want to not have that. And we may be able to simplify this radical to start with. So we can say that the square root of 90 is the same thing as the square root of 9 times the square root of 10. And we know that the square root of 9 is 3. So this is 3 over 3 times the square root of 10. Okay, we're kind of losing paper there. Let me scroll this down a little bit. We have 3 over 3 times the square root of 10. We can cancel out the common factor of 3 from the numerator and denominator. That gives us 1 over the square root of 10. And we'd almost be done, except we still have a radical in the denominator, and we generally like to get rid of that. Well, we can multiply by the square root of 10 over the square root of 10. And that will give us the square root of 10 in the numerator when we multiply across numerators. And the square root of 10 times itself is just 10. So that is our answer. The sine of theta is equal to the square root of 10 over 10. And let's look at our very, very last problem here. Again, we're given a triangle, but we're being asked to find the measure of the angle indicated and round to the nearest tenth. When you see something that says round to the nearest tenth, you know there's a good chance we're going to have to use our calculator for this. Okay, so it kind of tips you off that they don't expect you to get an exact answer, but they want to get a rounded off answer. So let's take a look and see what we can do with this. We've got to find out what theta is. And this is another right triangle. And what sides are we given with theta? Obviously, we're given a hypotenuse here, right? AB is the hypotenuse. You can see AB is the hypotenuse. And then the question is, well, if that's the hypotenuse, what is CA? CA, is this an opposite side or is this an adjacent side? Well, it looks to me like this is an adjacent side. So we're given the adjacent side to theta. Well, let's go back to SOHCAHTOA. What trigonometric function involves the hypotenuse and an adjacent side? That's right, cosine. Okay, that's the one that would be the easiest to use to calculate what theta is equal to here. Because the cosine of theta is equal to the adjacent side over the hypotenuse, which is 5 over 16. So the cosine of theta is 5/16, and we just need to figure out what theta is. Well, the way to do that is to take the inverse cosine of both sides, canceling out the cosine on the left. So we take the inverse cosine of both sides. Let me kind of squeeze that in up there. That gives us theta equals the inverse cosine of 5 over 16. Okay, so we go to our calculator. We've got to make sure we're dealing with degrees here, because if we're not dealing with degrees, then we're in trouble. Notice this is set to radians, so let's go to degrees, because I'll tell you that this test wanted the answer in degrees. We've got to make sure we're in degrees, and let's quit out of this. And we've got to find the inverse cosine of 5/16. So that means we're going to do second cosine, and we're going to put it in parenthesis. We're going to, oops, I did something wrong then. Let me clear that off. Let me do second cosine, inverse cosine. Okay, I guess I don't really need an extra set of parentheses. 5 divided by, I don't think you need me to show you the keyboard for that. 5 divided by 16. And let's see what we get. 71.79 to the nearest tenths. That would be 71.8, which is the correct answer. That is the correct answer to the problem. The answer is, therefore, 71.8 degrees. I hope that this very condensed and brief review, crash course, as it were, for the pre-calculus pretest is going to help refresh your memory and enable you to rapidly sort of get up to speed in these various areas. Good luck.